Hello everyone, I am Balaji Rao. Welcome to BR Maths class. This is second class in Relations and Functions, class 12th Mathematics. This is second concept. In this class, what we are going to learn? What is reflexive relation? What is symmetric relation? What is transitive relation? These are very important concepts in this relations topic. Many students confuse a lot to understand these things. But I'll give clear explanation about each relation with more number of examples so that all doubts will be clear in this class only. To understand exercise number 1.1 problems in these relations and functions, understanding these definitions is very important. Let's see what is the definition of reflexive relation. You see, reflexive relation. A relation R on A. A relation R on A, what it means? It means that R is a relation from A to A. Right? This we discussed in last class. A relation R on A, that means R is a relation from A to A, is said to be reflexive relation. This relation is said to be reflexive relation. This is important for every, this is important, you don't take it lightly. For every x in set A, order pair x comma x must belong to the relation. Then we say that relation is reflexive relation. You may confuse little bit here, but you can understand this easily with the help of examples. I'll take set A like this. Set A is 1, 2, 3. R is a relation on A means R is a relation from A to A. When we say R is a relation from A to A, when R is subset of A cross A. So I want to write A cross A now. If you want to write A cross A, how you will write A cross A? See, first I'll take set A 1, 2, 3 cross. Again I'll take set A 1, 2, 3 A cross A. How you will pair with? You take one element in this first set, you pair with all other elements in the other set, like 1, 1, 1, 2, 1, 3. After that, you will take this element to 2, 1, 2, 2, 2, 3. Similarly, 3, 1, 3, 2, 3, 3. You know that is A cross A. So I'll write A cross A now. This is A cross A. See, 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. You must know how to write A cross A. Now, how many relations I can form on set A? The formula is 2 power number of elements in A cross A. That is what? 2 power 9. So, 2 power 9 means 512 relations we can form. Now, I'll take one relation. You observe, I considered a relation. Is it is a subset of A cross A? If it is subset of A cross A, then only we say that it is a relation on A. You see, order pair 1, 2, yes, it is there in A cross A. Order pair 2, 1, yes, it is there in A cross A. Order pair 1, 1, yes, it is there in A cross A. Order pair 3, 3, yes, it is there in A cross A. So, it is a subset of A cross A. So, this is a relation on A. I taken a relation or on A. Now, I need to decide this relation is a reflexive relation or not. What is the definition? You observe, this is important. Every x belongs to A, order pair x comma x belongs to R. First, you come to set A, not to the relation. You come to set A. R is a relation on A. Na? For every x in set A, you take 1 in this set A. You take 1 in this set A. Order pair 1, 1 is there in this relation or not? You see here, for 1 belongs to A, I am checking that 1, 1 is there in the relation or not. See, order pair 1, 1 is there. For 1 belongs to set A, 1, 1 belongs to this relation. Can I say that this relation is reflexive relation? Can I say this relation is reflexive relation from this? No. You need to check for every x in set A. Then only you can say that for every x in set A, if order pair x comma x belongs to R, then only we say that this relation is reflexive relation. Suppose 1 is there, 1, 1 is there. That means we say that this element passed reflexive test. Now, we will come to the next element because they are asking for every element in set A. Come to the second element 2. For 2, 2, 2 is there in this. You observe, for 2, 2, 2 is there in this. No, 2, 2 is not in this relation. So, Actual condition is what? For every x in set A, x comma x must belongs to the relation. But here 2 is there in set A, but 2 comma 2 does not belongs to this relation. So we say that this relation is not reflexive. This relation is not reflexive. If you want to write the reason, you can write like this. Because for 2 belongs to set A implies 2 comma 2 does not belongs to the relation. Because of this reason, this relation is not reflexive. I hope you understand. Now, I'll name this relation as R2. You observe, it is a relation on A. When we say R is a relation on A, when this R is subset of A cross A. 1 comma 1 is there in A cross A? Yes, 1 comma 1 is there in A cross A. 2 comma 2 is there in A cross A? Yes. 3 comma 3 is there in A cross A? Yes. So this is subset of A cross A. So first point is it is a relation on A. Okay. Now is this relation is reflexive? Is this relation is reflexive? What is the condition? Condition is for every x belongs to A. This is important. For every x belongs to A, order pair x comma x belongs to the relation. You take here 1. 1 is there in set A. 1 comma 1 is there in this relation. Yes, it is there. That means we say that this element pass reflexive test. Okay. Now come to 2. 2 is there in set A. 2 comma 2 is there in this relation. Yes, 2 comma 2 is there in this relation. So we say that this element pass reflexive test. Okay. 3 is there in set A. 3 comma 3 is there in this relation. Yes, it is there. So we say that this element pass reflexive test. So finally what we say? We say that this relation is reflexive. And one more important point, as this relation is reflexive, while writing the answer, you cannot write that 1 belongs to A implies 1 comma 1 belongs to R. That's why this relation is reflexive. Like that you cannot say. You can write like this. If you want to write why it is reflexive, for every x belongs to A, order pair x comma x belongs to R. That's why this relation is reflexive. Now I'll take one more example to understand this reflexive relation more clearly. You observe, I consider one relation and it is a subset of A cross A. 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 2. Yes, all elements of R3 are there in A cross A. So this is a relation on A. Now I am checking that is this relation is reflexive relation or not. What is reflexive relation condition? For every x belongs to A, this is important. For every x belongs to A, order pair x comma x belongs to the relation or not, you need to check. Okay. Now, as this is a relation on set A, you come to this set A. Here, 1 is there in set A. 1 comma 1 is there in this? Yes. 2 is there in set A. 2 comma 2 is there in this? Yes. 3 is there in set A. 3 comma 3 is there in this set? In this set? Yes. Here some people will doubt. Here 1 comma 2 extra is there na? Because of that how it will be reflexive. That is not the question here. Here the question is this relation satisfying this condition or not. For every x belongs to A, x comma x belongs to relation or not. That much only. You see here, for 1, 1 comma 1 is there. For 2, 2 comma 2 is there. For 3, 3 comma 3 is there. So we can say that this relation is reflexive as it is satisfying the reflexive relation definition. So this relation is reflexive relation or not? Yes, it is reflexive relation. Now, like this, how many number of reflexive relations we can form? Total number of reflexive relations. We have a formula for that. You see, we have a formula for total number of reflexive relations on A. The formula is 2 power n of A whole square minus n of A. So, total number of reflexive relations formula is this one. In this case, how many number of reflexive relations are possible? Right? The set A contains 3 elements. Na? So number of reflexive relation on that particular set is what? 2 power n of A is 3. 3 square is 9 minus n of A is 3. That is 2 power 6. 2 power 6 is 64. Like this, on this set, total 64 relations. Here I written 3 reflexive relations. Na? Actually, we can form 64 reflexive relations on this set. I hope you understand about this reflexive relation. Now we are going to learn about symmetric relation.
It's not a game, it's a rich thing.